Hey everybody, hope you guys are having a good evening. Looks like these are hopefully going to be up by 3:30, but it's going to be close. Right now it is 3:21. I had to fix a mistake in the, on the notes, so go ahead and get these up. Alright, so we're going to start with Polynomial Basics. There's going to be a lot here. I'm going to suggest that you actually pause it on the couple of these screens so you can get some stuff copied down. So Polynomial Basics, we have our exponent rules. So the first one is exponential form, and that is just that the base raised to an exponent equals a number. You have multiplying bases, which says when you multiply the bases, you have x squared times x to the third. These are like terms. So when I multiply them, I'm going to do x to the 2 plus 3 power. You add the exponents, and that gives you x to the 5th. You have dividing bases. You have x to the 4th divided by x to the 3rd. Since the x's are the same, you actually subtract the exponents. That gives you x to the 4 minus 3, which gives you x to the 1st. You have power to power, which means when you have a base and an exponent and you raise that to another exponent, you're going to multiply the exponents, which gives you x to the 6th. You have product to a power, so what they're saying is you take a product, something inside inside parentheses, you're going to raise that to an exponent. You're going to just distribute the exponent, so that gives you a to the n power times b to the n power. And then again, same idea with the quotient to a power, so I have a divided by b raised to the n. That means I have a to the n and b to the n power. I know I'm going through the rules quickly, and I'm going to show you the definitions as well. You're going to need to pause this and actually write these down. And for the definitions, you will be required to have the definitions written on a separate sheet of paper with the definition from the dictionary, or you can actually just copy these definitions down, would be fine as well. So the 7th exponent rule is just for evaluation. If you have x to the 5th power, that means you're multiplying x by itself 5 times. So there'd be 1, 2, 3, 4. I have 5 x's and I multiply it by itself 5 times. The negative exponent rule, I have a very basic one here, and then I'm going to show you a little bit more involved one. So I have x to the negative m power. What happens is I take this here, and I'm going to move it to the other side of the fraction, and the m becomes positive. So this is the same thing as 1 over x to the m power. Another example I'm going to use, and this one's a little bit more involved so you can actually see what happens. I don't want you guys to think that you're just flipping the fraction. That is a reciprocal. That is not what you do with the negative exponent. So I have 2x to the negative a y over z to the negative 2nd. Well, the exponent of 2 and y is 1. So I'm going to take just the base with the negative exponent, and it goes to the other side, which means z to the negative 2nd goes up. And I apologize, this was actually supposed to be a 2. So let me actually write that as a 2 real quick. Okay. So now the x to the negative 2nd went down, the z to the negative 2nd went up. So this is the same thing as 2y z squared over x squared. The 2 and the y stay on top where they were because they were a positive exponent, not a negative exponent. Okay? So that's a quick rundown of the exponent rules. The definitions we're looking for, polynomial, monomial, a constant, a binomial, a trinomial, a term, a coefficient, degree of a term, degree of the polynomial, and then the last one is descending order. And those are going to come into play in the 3 examples we're doing and on your worksheet for tomorrow. So go ahead and you pause it here, get all this written down, and that'll work. So example number 1. We're just going to start off basic. We're just going to be simplifying a lot right now. So this is negative 7x squared y to the 5th times 4xy to the 3rd. So I'm going to, when I do this, I'm going to multiply all like terms together. I'm going to combine the like terms. So negative 7 times 4 is negative 28. Now this is going to be x squared and I'm going to write a couple extra steps that we'll be able to skip in the future. X squared times x times y5 times y3. I'm going to use the multiplying bases rule because I'm multiplying the bases. So I'm going to add the exponents. So this is 2 plus 1 times y to the 5 plus 3, which gives me negative 28 x to the third y to the 8th. And there is my answer. Now we're going to go to example number 2. Okay, and this one isn't so much doing simplifying. This one I got a few questions that are actually being asked that you're going to be required to answer. So it says, answer the given questions about the polynomial. Your polynomial is negative 7x to the third plus 6x squared plus 3x plus 7. First thing it asks is, what degree is the polynomial? Okay. Now, in order for you to determine the degree of the polynomial, from your definitions says that it's the degree of the highest term, and the degree is based on the exponent. So it's basically whatever term has the biggest exponent. So this is a term. I'm going to underline all the terms. Here's the first one, second one, third one, and the fourth one. And you look at whichever one has the highest exponent, that's your degree. So the 3 is the highest, so the degree of my polynomial then is 3. How many terms are there? Well, we underlined them, 1, 2, 3, 4. What is the degree of the second term? Now, in order for you to be able to determine the degree of the second term, these have to be in descending order, which means you're going to take, descending order is always determined alphabetical order, okay, so there's only one variable, so it's going to be based on the x, and it's exactly what it sounds like, descending order, which means that the exponent descends as you go. So it's 3, 2, 1, and this would be x to the 0 power, because x to the 0 power is 1, 1 times 7 is 7. So now they're asking, what is the degree of the second term? So here's my second term. The degree is based on the exponent. So the degree would be 2. The last question for this one says, what is the coefficient of the second term? Coefficient from your definitions is the number in front of the variable. So this is my second term. The number in front of the x squared is 6. So my coefficient then is 6. Okay? This practice here is strictly just determining, do you know the definitions? Do you understand when I say the degree of the polynomial? Do you understand what that means? Do you understand what the degree of a term is? Do you understand what a term is? Do you understand what a coefficient is? So there's lots of different things that this is testing, but it's really just testing the definitions and your understanding of them. Okay? So now, when we go on to the next one, this one's going to be a little bit harder. First thing it tells you to do is put them in descending order. Okay? So here you notice that I have a y and an x. Okay? Descending order is determined upon alphabetical order and the degree of that exponent. Okay? So here I want to, all of my terms are going to be put in order of whatever variable comes first alphabetically, which is going to be x. So I want to write the term that has the x with the biggest exponent first. So that's going to be this term here because I have x to the 5th. This has an x to the 0 power, x to the 2nd, x to the 1st, and x to the 3rd. So I'm going to write this one first. So that's 4x5 y2, and now I find the next smallest exponent. All right, so the next smallest, I have an x squared, I have an x0, I have an x1, and I have an x3. So the next biggest is going to be the x3, so that's going to be my next term, plus 3x to the 3rd. And then again, I have x1, and remember, when there is no x here, it's always going to be x to the 0 power, because that's just going to be 1. So it looks like my next one is going to be minus 4x squared plus 5xy plus 3y. Okay? Now you can tell it doesn't so much have to do with the y's, because you can tell I have a y here and I have a y here, and I have no y and no y. Okay, so it's not determined by the y's, it's only determined by the x's in this case because x came first alphabetically. So now I'm going to look at this rewritten polynomial here, and I'm going to answer the rest of my questions. What is the degree of the polynomial? Okay, for the degree of the polynomial now, it is going to be just slightly different than the last one. Okay, so the degree of the polynomial here is going to be based on the highest one, okay? And it's slightly different because it's not just based on, if you look at the last one, it was based on just, no, not this one, sorry. It was based on just the x because there was only an x here, okay? Now on this one, the degree of the polynomial, you have to consider the degree of each term. And the terms, the degree of the terms is based on adding the exponents of all the variables in that term. So for example, in green, we'll go ahead and write what the degree is. So I add the exponents together. So 5 and 2, so the degree of the first term is 7. The degree of the second term is 3. Third term is 2. The fourth term, this is a 1 and a 1, so this is going to be a 2, and this is a 1, so that's a 1. So now again, you're writing the degree of the polynomial, so it's going to be the highest one, so it's going to be 7. How many terms are there? Well, there's 1, 2, 3, 4, 5 terms. Remember, terms are always separated by addition and subtraction, not multiplication and division. So I have one term here, it's separated by an addition. Here's the second one, third one, fourth one, fifth one. What is the degree of the second term? So again, I look at the second term, I add up all the exponents of all the variables. So there's just an x to the third, so the degree of the second term is 3. And then what is the coefficient of the second term? The coefficient again is the number in front of the variable, so it is going to be a 3 as well. Make sure you guys write down any questions you have about this. There will be an assignment on it tomorrow. So come to class prepared tomorrow to get this done. Have a great night.